Let me work through a couple of problems with you that are dealing with a normal distribution, and the normal distribution is transformed over to a standard normal distribution. What I want to do is I'm on page 303, and I'm going to work problems 8, 9, and 19. And we can talk about some things as we go, but let me start with number 8. Number 8 says I have a normal distribution with a mean of 100 and a standard deviation of 10. Now, when I'm going to draw a picture of this, which is what it's asking me to do, I have to decide for Excel where the ordered pairs should be, because that's how Excel draws pictures. It's going to assume in my table over here that each row represents an ordered pair that it's then going to graph in my picture over here. Okay? So I want to know how much to draw. And from some of our rules from earlier, things that we know that 99% of all of my random variable values should be within 3 standard deviations of either side of the mean. So I have been constructing where these standard deviations should lie. So here I have the mean plus 1 standard deviation. Here I have the mean plus 2 standard deviations. And finally, the mean plus 3 standard deviations. I am using that information to try and construct my ordered pairs. Okay? So I'm going to start at 70. And what I need in order to create an ordered pair is I need to know what the normal distribution's function value is at the number 70. So I start in typing norm.dist, normal distribution. I need the x value I'm interested in, and that would be the number 70 that's sitting in cell A2. I need to know the mean. The mean's not going to change. It's always going to be 100. So I got to make that an absolute reference. And then it wants the standard deviation. It too is not going to change, so I'll make it an absolute reference. And then it's asking me about cumulative or mass function. Now, there really is no such thing as a mass function in the continuous case. So really what that means is just evaluate the function at the x value. So I am in this case going to choose false because I'm drawing a picture. If I were calculating a probability, I really wouldn't be able to choose as false. So let me put that in there. And I already have my picture ready to be outlined, so let me put in a few values. And you see that it starts to take shape. Notice that I have chose to increase my random variable by 1/10 each row. Now, here's some things to think about. First off, I won't be able to get a probability between 70 and 71 by just adding up these 10 cells, because this sum of 0.005 is wrong. Now, any guesses why? If you guessed that it has to do with between, and remember this is a continuous distribution, so there is mass in between 70 and 70.1 that is not being counted in these numbers. So what I have, and the reason I can't just add up these numbers to get the probability at between 70 and 71, is I have a bunch of holes in my data, which I hope gives you an idea of why I can't really talk about probability at a point anymore, because a point has no mass. Does that make sense? In other words, you know, a one-dimensional point carries no mass. In the lingo, we would say something like there are no sets of measure 0. There's no gapping in here. But here in the table, there's gapping. All right, now, what I'm going to do, because it's going to show up later, is I'm going to go ahead and I'm going to change the look of my plot here. Okay, well, let me try again. Just choose the horizontal axis. Okay, here's what I want. So what I did is I clicked on a number. As you can see, a box went around those numbers, and it's asking me for the smallest value. Well, I'm going to let the smallest value be this 70 over here. So I'm going to put it in as 70. I'm going to let the maximum value be this 130. And then I'm going to let it jump just like this did, 10 units at a time. And then I'm going to call that good. And notice I have now a picture of my normal distribution. All right, now, are there any other objects or any other things that were asked in number 8? And the answer is no. What we did is we were asked to construct a normal distribution. We were given a mean, a standard deviation, and we were asked to plot the 6 standard deviations starting over here at the left. And we're going from 70 to 80, that's 1 standard deviation, 2, 3, 4, 5, 6, and so on. So we are plotting 6 standard deviations, which according to our empirical rule, 99% of all of the area that's underneath this curve will occur within that 6 standard deviation bandwidth. Let me move to a different problem. This problem, I've already set part of it up. I didn't want to just recreate this since we don't need to, but I have created the picture that we'll be using over here on the right to answer certain numbers of questions. So here's what I have. In part B of number 9, I am asked to calculate the probability that my random variable x will lie between 45 and 55. Now, there's some things that I should notice instantly. That is 1 standard deviation to the left of the mean and 1 standard deviation to the right of the mean. So I know that this probability had better come close to 68% or 0.68, because that's what the empirical rule tells me about the probability of being 1 standard deviation on either side of the mean. So how do I calculate it? Let me focus right here that what I need is the probability, the cumulative probability, that x takes a value less than 55. So the number that I'm calculating will represent the area underneath this curve starting here at 55 and going on over to infinity, negative infinity. I'm going to subtract from that the area starting at 45 and traveling left out to negative infinity. When I subtract those two areas, I'm going to end up with an area just between 45 and 55. Okay, so here we go. Here's how I do it. Norm dot dist. The value of x that I want is 55. The mean is 50. The standard deviation is 5. And cumulative is true. Okay. This, if I push return, what I can say is that 84% of the area under this curve is to the left of the number 55. Okay. I need to subtract from that, so I'm going to go finish this. I'm going to subtract from that the area to the left of the number 45. So 45, the mean is 50, the standard deviation is 5, and yes, I want the cumulative. So I want all the area from 45 and left. And notice it's what we expected. It's about 0.68, or what we have just discovered, again, is that 68% of the random variables in this sample should lie between the number 45 and 55, which is 1 standard deviation to the left and right of the mean. Okay? Let's try this again. This time I want the probability that the random variable takes a value between 40 and 60. And again, maybe it's the author, but it's convenient. That is 2 standard deviations to the left and right. So in essence, we're testing the empirical rule again. So let's give this a shot. Here's what we know. It should come out somewhere around 0.95. So norm.dist, the value of x of 60, the mean is 50, standard deviation is 5, and yes, I want the cumulative distribution. I want all the area from 60 and left. And again, if I stop here, it's all the area from 60 and left all the way to negative infinity, which is 97.7% of the area. Okay? Well, I am going to subtract from this norm.dist the area to the left of the number 40 when I have a mean of 50 and a standard deviation of 5. And again, I want the cumulative distribution. And there's my 95.5%. So I anticipate that if I were viewing this process and collecting random variables, that every random variable that I collected, approximately 95.5% would be between the number 40 and 60. All right, let's finish up this problem 19. 19 is a little different, but not much. Once again, I'm using the distribution. If you think of 19, if I were thinking of 450 greater than that, I'm looking at an area now to the right instead of to the left. So I have to be careful with how I calculate this probability. I'm going to calculate it as 1 minus norm.distribution. I'm interested in the number 450. I have a mean of 367 and a standard deviation of 88. And yes, I am going to take the cumulative density. So there's a 17% chance, or a probability of 0.17, that when I take my car to the repair shop, the cost will be above $450. Okay. So we should have known that. We saw that coming. We've got that the value that we're looking at is greater than the mean, so certainly going to be less than half here. Let's try this one. Notice that this one, I'm looking for values to the left to 50, so that's just equal to norm.dist. The value is 250, means 367, standard deviation is 88, and I do want the cumulative distribution. So the probability that my cost is going to be below 250 is 0.09. And now I'm looking between. Okay, so I could almost subtract part A and B, but except that wouldn't quite be right, because in A I'm looking for values above 450. Here I'm looking at values less than 450. So let me write this, norm.dist. And this should be reminiscent of problem 9, which we just finished a moment ago, where I take the difference between the areas bounded by 450 and 250 when I have a mean of 367 and a standard deviation of 88. And I can say that 73% of all of the costs are between $250 and $450. Now, part D is a slightly different question. Let me go over and reread that. If the cost for your car's repair is lower in the lower 5% of the automobile repair charge, what is your cost? So this one's asking me a different question. In fact, I probably should even phrase this different. I am looking for a value of my random variable, which is less than or equal to 250. Is that what it asked? 250? Sorry, 5%. So I'm actually looking for an inverse. You know, I'm getting caught up here in the way it looks. I'll repair this later. Okay? But I'm actually looking for an inverse this time. In other words, they're telling me that there's 5% of the area to the left of some number. And I'm looking for that number where 5% of the area is to the left of the number. So I'm actually looking for something called norm inverse. I need 5%, and I need the mean, the standard deviation, and so there's a less than 5% chance that my bill is going to be less than $222.25. Okay. Some of you have also asked, well, what is this z value? One thing that we really like about the normal distribution, it is very malleable, meaning I can take any distribution, including this one centered at 367 with a standard deviation of 88, and I can transform it to something called a standard normal distribution, which means I can take any normal distribution and I can compress it into one standard way to view it, which means if I have a table of values for probabilities, I have any normal table, I just need a single table. So let me do this z value. What it is the value of x minus the mean divided by the standard deviation. Here's how I interpret that number. The number 450 is 0.94 standard deviations away from the mean. Okay. And I could do a probability calculation with that. It would be norm dot s dot distribution. So the dot s tells us standard normal, so that means this function knows what the mean and the variance is. The mean is 0 and the variance is 1 because we forced it to be a standard normal. So I want the probability to the right of this number, which means I'm going to have to do a 1 minus here in a second, and I want the cumulative. Right now, if I push return, I'll have the area to the left of this number. I want the area to the right, so I'll put the 1 minus that. And notice that these two numbers are identical. So in the bad old days, before we had computers, every standard normal distribution was transported over to the z value, and we used a standard normal table. It was easy that way because the standard normal table, I only had to have one of them. Okay, but if I had to have a table for every mean and every variance, I'd have had to have had thousands of them. So let me use this z value again. It's the value of x minus the mean. Notice this one's going to come up negative, divided by the standard deviation. So 250 is 1.329 standard deviations to the left of the mean. And I can calculate the probability using the norm.s dist, the z value, cumulative is true. When I push return, it had better come out 0.09, where I did something wrong. Okay? All right, notice that they did come out the same. Let's do it over here. Okay, let's do it over here. Let's calculate the z value. We know what they are, but let's do it anyway. 450 minus 367 divided by 88 should give me 0.9. I'm going to do 250 minus 367 divided by 88 for a value of minus 1.32. And now let's calculate the probabilities. Norm.s.dist of z, cumulative is true, minus norm.s.dist minus 1.329, cumulative true. And again, I'm going to push return, and it better come out as 0.7353. 0.372. Okay. All right, so the z value is just it is called a transformation. It's me taking a normal distribution centered somewhere in space and repositioning it to something centered at 0 with a standard deviation of 1. You can ask me more questions about that. I'm kind of running out of time here, so let me push this forward, and I hope to talk to you soon, hopefully more about these probabilities.